Hi guys, in this video I want to walk through this LeetCode number 144, binary tree pre-order traversal. So let's look at the example in here. So we have a tree looks like this, and the key to remember about this tree, this pre-order traversal is that it goes from the root and then to the left first and then right later. So as we can see, for a tree like this, and it's 1, 2, and 3 because the left node is empty. So it go to the right node and then go to the left of the right node. And these two cases trivial. And for this case is go to the left and there's nothing on right, so it does nothing on the right. And in here there's nothing on the left, so it go to the right. And so this is one of the three method for traverse a tree. So we have pre-order, in order, and also post order. And we will implement this pseudocode. We will look at this pseudocode and implement it in Python later on LeetCode here. So another example, as you can see the tree in here. So we have 1, 2, 3, and 4, 5, 6, 7 in here. So the first one, the root node is 1, so we're displaying a 1 here. And we have the left node is 2, and within the left node we have 4 and 5. And then after we have to finish this branch, and then we go for the right branch 3, and within the right branch we go from the left first and the right later. So a recursive way. There are two approaches to do this, and as you can see on the left hand side, so this is a recursive function. So we have pre-order, we put in the node. If the node is equal to none, we return nothing, and then we have to visit that node already, so we make note of that, and then we recursively calling the left and the right. So we displaying the root node, the value of root node first, and then recursively call the left branch and then the right branch. If we are reaching the child node, the leaf node. So we reach to the bottom. So we don't do nothing. And to do that, to implement that, we can do like this. So if the root is equal to none, we just simply do a return, and otherwise we return the value itself. So we have the root dot val, and then concatenate what is returned from the left and also what is returned from the right. So when the node is a child node, a leaf node, and it's in that case we just return a empty list. Otherwise, it's recursively calling on the left leaves and the right leaves, so it passed all the test cases. So, for example, when we are giving a root node of 1, and then we have 2 and 3, so the 2, and then when we call the 1, so that will be the value in the list. So we have 1, and then 2 and 3 will be the left and right. And then when we go to the 2, we have 4 and 5 in here, and 5. And the 4 has no more child, so it's a leaf node. And that's the case when it captures the 4. and just return the empty list. At the same time, it captures the 4 as in value, also 5 as in value, and go back to this node and then capture the 2 as in value. And the same thing happened on the right hand side after we finish the left branch. So this is a recursive. This is a recursive way to do this. And there's another way is an iterative approach. We can use a while loop. As you can see, we need to use a stack. So if the node is a none, and then this is a trivial case, so just return nothing. And then we initialize a empty stack, and then we push the root node to the stack while the stack is not empty. We pop off the element. So a stack, the principle for the stack is the first in, is the last in and first out. So that's a stack. So it's not the same, it's opposite of the queue. Okay? A queue is first in, first out. A stack is last in, first out. So we pop it off the latest element from the stack, and we take the value, and then we push in the left child, and then we push in the right child. So when we pop off the element, so the left child will come out first, and then it will come out the right child. After the left child comes out, and then you look at the children of the left child. We first put in the right hand side, and then we put in the left hand side and do the same thing in this for loop. So let's implement it in this iterative approach. I'm going to comment this out. Okay, so in the stack, so empty list to start. And before that, we also have a let's put the pseudo codes in here, so just for our reference. And if the case where if the root is none, that's a trivial case. You just return an empty list. And otherwise, we initiate a stack, and the stack will have a the first root node. We can append the root node to it. So, and then while the stack is not empty, and we can have a temporary, just temporary, equals to stack dot pop. And also we need the answer list, the collecting all the values, and dot append temp dot val, and if temp dot we go right first, because when we pop it off, we'll pop off the latest one, which is the left one. That's why we push in the right first. If the right is not empty, it's not none, what we're gonna do, we'll push it to the stack. Stack dot append the right node, Same thing, then do it for the left. To the left. Okay. Yeah, I think this will do. Let's try it. Return the answer. Fix a little box in here, so this should be a double echo. It's checking the condition. So I'll pass this test case, and let's submit the code to see if that runs properly. Yes, it does. So as you can see, this is another approach. It's a iterative approach. We use not recursively calling, as you can see here. That's the first approach, recursion. Another one, this one is iterative. We're using a for loop and also a stack. This so much we solve this problem, binary tree pre-order traversal. And I hope you like it, and hopefully I see you in the next video.